Hello everyone. Thanks for checking out my video here. This particular video will be about looking at quadratic function properties. In particular, we want to look at a quadratic function in terms of its vertex and its axis of symmetry. And we want to be able to do things such as look at a particular function in one of its forms and be able to, well, regardless of what form it's in, whether it's in this perfect square form or in this canonical form, and be able to figure out where the vertex is, axis of symmetry is, in general how the graph looks, whether the graph is increasing, decreasing, constant, all those sort of things. So we start off here by looking at this particular function g of x. And so we see that g of x is -2 times x minus 2 squared plus 7. And so if we look over here, we'll see that this is a summary of our quadratic function properties. And so notice that this is the canonical form for the quadratic function, and this is the form where we have the perfect square in there. And in either case, a is not allowed to be 0. Now, it turns out that how we get from this form to this form of a quadratic function is by completing the square. And if you've watched some of my previous videos, you've seen how we actually do the process of completing the square. If not, please check it out. So in general, if we do completing the square from this form of the quadratic function to this one, we end up with h being minus b over 2a, which represents the x coordinate for the vertex, and we have k end up being 4ac minus b squared over 4a, which is the y coordinate for the vertex. And so the x coordinate for the vertex doubles also as the number for the line of symmetry here. So x equals h would be the vertical line for the axis of symmetry, and that's the line in which the actual parabola is symmetric by. Okay? And so we also see here that if a, which is our leading coefficient here, which is the same a that's here, if it's positive, then we know that the parabola opens up like this, and that the vertex is a minimum point on the graph, and then our range goes from the y coordinate from the vertex on up to infinity. And similarly, if our value for a is negative, then we know that our parabola opens downward. And we also know that the vertex is a maximum point on the graph, and that the range goes down from, well, comes from negative infinity and goes up to the highest point on the graph, where that point's y coordinate is what k is. And so the range would be from negative infinity to whatever k is. So in general, this is a summary of what the quadratic function properties are, and we're going to use that to answer the following questions that we have here. So I'm going to go ahead and clear this out and give ourselves some room to go ahead and do some extra work. So I'm just going to go ahead and move this over. All right, so with that being said, now let's go ahead and start to work on this problem. So we have our g of x is a -2x minus 2 squared plus 7. And so from what we've seen, we know that a is -2, h is 2, and k is 7. So what that tells us is that first off, we know that we have a point 2, 7 that's on the graph, and that's going to be your vertex. Okay. The other thing that we know is that we have a is -2, so that means our parabola will be opening down. So if we had to kind of guess what our graph would look like, it would look something like this if we were drawing. Okay? So if you notice here, we're asked to draw a graph here using some points. So we know we need to have at least 2 points here. So we know the point 2, 7 is 1. The other point we could find, we could go look at the y-intercept to do it, or we can look at the axis of symmetry to do it. I'm going to show you how to do it both ways, so that depending upon what your Cartesian planes x window and y window are, you'll be able to find what you need. Okay, so if we looked at this in terms of its y-intercept, which would probably be this point there, we know that we would have to plug in 0 for x to figure it out. So let's do that. So if we let y, which is same as g of x here, if we let y equal -2, plug in 0 in for x, then we'll see that 0 minus 2 is -2, and -2 squared is 4. So we do that, it's -8 plus 7, which gives us a -1. So we know another point that we have on the graph is the point 0, -1. Okay? Now, knowing that we have the point 0, -1 here, and that our axis of symmetry should be the line x equals 2 here, we also know that 2 units away from the axis of symmetry over here, so in other words, when x is 4, we should also have a point 4, -1 as well. And so, of course, I don't necessarily have that drawn correctly here. The graph kind of goes more like this. So I'll go ahead and redraw this right quick to make it reflect more of what it should look like. Alright, so with the graph redrawn to what it should look like, then we know that if we have a point 0, -1 here, then 2 units away at x equals 4, we should also have a point 4, -1 as well. So we want to go ahead and do that. So at this point, we'll go ahead and use our graphing tool, define our vertex, which is the point 2, 7. Should be here, and then our point 0, -1, which is there. And we also see that at the point, and we'll go ahead and zoom in so we can see this better. So here at the point x is 4, we see that it also intercepts right there at x equals 1 as well. I'll make that a little bigger for you. So 1, 2, 3, 4, right there. It crosses right there. And of course, our axis of symmetry is at x equals 2 right here. So with that being said, go ahead and save that. Check it, and we'll see that we don't have a problem. So for our next question, it says, what is the domain and range? Well, we know that a quadratic function is like a polynomial. And so the domain of any polynomial is all real numbers. The reason that we know that is because we do not have any variables x that are in the denominator of the fraction, and we do not have any even nth roots anywhere as well. So we can simply say that our domain is the set of all real numbers. So our range, since we know that this particular parabola has a maximum point, its vertex is a maximum point, I should say, we know that the highest y value is going to be 7. So our range should be from -infinity, and it keeps on going until we get to 7, and then we'll end with a bracket, meaning that 7 is included in the range. And then now we want to see whether the function is increasing. So we know that looking at the graph, the function increases and then it decreases. Where it stops increasing is right at x equals 2, which is right where we have our vertex at and axis of symmetry. So here, one thing we have to remember is when we answer is a function increasing, decreasing, or constant, is we need to make sure that we answer in terms of x values and not in terms of y values and not in terms of from point to point. We answer in terms of x values, and we always answer in an open interval. So keeping that in mind, we know that we're going to go from -infinity, so basically way over here and coming up till we get to the value of 2. So that would be when our function increases in terms of x values. Our function decreases on the other side of that. So if -2 to -infinity to 2, is where the function increases, and then from 2 to infinity is where the function will decrease. So we'll go ahead and do that. And so that's pretty much it for this particular problem.